Hello everyone, hope you're doing well. Um, I just happened to open the notes file, and first of all, I was thinking on implementing the attack feature, but then I noticed that we got a bunch of these things already done, so we can remove these from the file. We already switched from TCC to GCC back again because of the error messaging, and then I fixed this offline. And then I also took care of this offline, which means the only thing that we gotta do is attack. Before that, though, I would like to address this point. Redirect the output from standard out to a file. Now, the reason for doing this is because we can print as many messages as we want, but if for some reason the server crashes or the terminal gets closed, we'll lose all those logs, which is not ideal. So instead, what I do now is, no, this is not here. From the bat file, the one that opens up the game server and the login server, we're running the game server, but at the same time we're redirecting the. So first of all, now we're no longer using std out. Instead, we're using std error. So and the reason for that is because we don't have to flush the buffer in order to print the messages. Uh, something something that we do have to do with std out. So we're redirecting the std error back to std out so we can see the logs in the terminal. But at the same time, we're piping all the logs or the messages into this game server text file. And we're doing the same for the login server. Now, if we take a look at well, actually I can clear this up and this too. And then let me show you what it looks like. Okay, so now you can see that even though we're printing to std error, since we are redirecting that to the std out, we can see the logs in the terminal, but at the same time, we're printing those logs back to the file, back to a file, as you can see here, right? So now there's no way to lose the logs. Also, one very important thing is that the logs will print even if the server crashes for some reason. And one of those some reasons is using assert, right? So in the game server, let me show you a quick example. Uh, New connection. Sure, I guess we can do it in here. So we'll assert something that will never happen. So we crash the server and we'll say, hello, this is a fail assertion. Okay, so previously we were crashing and there was no way of telling what went wrong. Now with this, if I open up the game server, actually I have to build this. There we go. Can open this up, login server, there we go. Now let's open up the game. And now we will crash as soon as I try to log into the game. So we got the game server there, then I click OK, and the server crashed. Now, previously, as I said, we weren't able to tell what went wrong. Now it's just a matter of open up the game server text file to check that now we got the assertion that failed or the reason why the game server crashed or the server crashed, right? As you can see here, today, assertion 0, hello, this is a fail assertion, fail online, so and so, and the file. So I'm super excited about this. Anyways, so now I'm gonna get rid of that. And I guess I can clean this up as well. What? Oh, okay. Alright, so now let's go ahead and implement the attack feature. Let's see. Game server. If I recall correctly, um, let's see. On game server request or new request, whatever. So this happens when we get a action packet, right? So just to test it out, I'm gonna say maybe I wanna I how can I do this? Well, first I want to make sure that I'm sending the correct packet, which should be I'm gonna close this. I think it should be launch attack or something like that. We'll see. Okay. So launch attack. Maybe not. Hit or attack request. This is inside server packets. I think this should be it. Attack. Then the hits. Alright, so in theory, we should send this. And the character should attack the target. So let's try that out. I'm gonna say game server response attack target, and then I'm gonna pick the character, which is gonna be the attacker, and the target. Should I? Well, I guess that's fine for now. Alright, so make sure that we're getting the destination as always, the attacker, and the target. There we go. And what else? Packet type. Attacker ID, alright. EU32. And this is gonna be attacker ID, if I recall correctly. I think I can do this, right? Alright. D what was the, I think it was integer, and then H is for short. Alright, so we're gonna pass the target ID as well. The damage, I'm gonna say um, U32 damage. I'm gonna say 10 just for now. Just a test. And then I can send packet right U32. There we go. I'm not sure what are the flags that we can use for this. Is it like critical stuff or? Oh. Hmm. Okay, so soul shot, critical, shield, and miss. Okay. Okay, so for now, we're not gonna send any flags. Uh, U8. So we already got the damage, the flags, and then X, Y, and Z. Um, that from the attacker? Yes, that's from the attacker. So packet right, E32, destination, attacker, X, Y, and Z. And finally, how many hits do we have? Which I think for now we can say we don't have any. I mean, yeah, I don't know why we have to send, like, if we got multiple hits, like we have to send one hit in here and then the rest as a list. Like, I don't know why we can't send everything in the list, but yeah. So for now we don't have any hits. So I'm gonna say hits count 0, and then we can do hit counts. And then this is U16. Alright. So now this should be it. Let's see if I can use that. We got the action, that's fine. Target, and then target response. Alright, so I think we can comment this and test the new response. Like so, Q response, and then we need to send the attacker, which is gonna be session character, and then the target is gonna be just target. I think we wanna also make sure that we always get a queue response, and that's it. Or I think I gotta add the header game response.h. Okay. And let's add this bad boy right here. There we go. Can I compile? Yes, I can. Alright, so game server, login server. Let's see if it works. Okay. Then test 2. Test 2. Maybe we can do, yeah, go. Let's see. Oh, the gamepad. Alright. And why is the Jesus Christ? Gamepad. Okay. Let's see if I. Hey, look at that. Nice. Oh, but the. Okay, so we were able to throw one hit and the server exploded. Let's see if we can see anything in the logs. Uh, Game server. What went wrong? Alright, look at this. The logs are working. Uh, so for some reason, we're hitting this. Response queue count +1. Are we resetting the queue count? I'm assuming we are, but Linux game server. Very nice. I'm very happy with the how the logs turn out. Because if you think about it, notice how we don't have to deal with files. We don't have to open, close a file, deal with handlers and things like that. We're just delegating that to the operating system, and we're just using the standard. Linux game server. Yes, we are resetting the queue count. So why are you hitting this? 78. Um, how many, um, let me check the game session. How many packets can we queue? 8, up to 8. And we're queuing, like, I don't think we're queuing that many responses. Like, we're not doing anything. Mm-hmm. We do that, response size. And then we queue this one up. And this happens when we can write back to the client. Maybe we're, hmm, make sure we can reuse responses. Yeah, this can be the problem. But it shouldn't because we don't, again, like we're not making that many actions. We should be able to, Having 8 packets should be plenty of room to handle all the packets that we do. Maybe we got a block that prevents this from executing. Packet size, response size. So what do we, uh, response size 34. Where is this one? Response size. If we haven't sent the entire thing, just exit. Yeah. And then come back again and try to keep flushing what's left from the response. And then when that's up, we reset the buffer, we reset the written count, increase this. Yeah. That is weird. Network write socket. The buff plus the count written. Response size minus count written. Yeah, this all seems to be fine, so alright, let's see what happens if we increase the buffer size. In-game server. Alright, let's see now. Test and test 2. I may have to disconnect the control. Alright, so then I hit. There we go. Can I keep walking? Yes, I can. Hit. Alright. Hit. Very nice. And do I see from the other client that I'm being hit or no? I think I'm not broadcasting the packet and I should. Yeah. Let's see. Let's try to broadcast this. Um, should be here. There we go. We find a free buffer. and we send, yeah, this is not correct. I'm gonna change this session so we refer to the actual attacker and then S to send this. And that should be it, right? See, there we go. Now if I try to attack, do I see that in here? Yeah. So now we're in the aggro state. Let's see if I can see the attack animation. Hey, look at that. Nice. So it's working. Perfect. And increasing the buffer size seems to uh nope, there we go. So we crash. Let's see what do we got now. Yeah, again, we're getting the same issue. There, um, game server. Yeah, the thing is, this is all wrong because we should be freeing the space. Like, we should be able to reuse the buffers that uh, were sent. Like, it doesn't make sense to wait for the whole buffer to be flush before reusing those connections. So how can I do? How can I do this? So in the game session, I think I can say struct or size team response queue head, and then uh, in the game session when we ask for a free packet or buffer, I think we should say, or maybe we can say response queue or free response queue index, something like that. Then in here, there we go. Let me think about this one second. Do we need this new index? What if we say what if we do something like that, and then so this one will be used, meaning mm, whoops. So we get the list of free buffers, right? We'll begin here. This is the free buffer that we will return. Then the next time that we call, we have to return this one, right? When one of these gets sent, which it should be in order, like, right, that's the other thing. We have to maintain the order of the packets. Otherwise, we're gonna have the same error that we had previously, where the client desyncs and everything goes to shittown. Well, I guess we can. What if we do response again, queue head? Whoops. And then in here, I'm gonna do that. I'm gonna say session response queue head. And then I have to make sure that we don't overflow. Like again, we get the buffers, right? We start here and then we move along. And then I think we can do, when we reach to the end, we'll go back to 0. So this should be if we overflow. So if we overflow, go back to the queue head, go back to the beginning of the list, and then we have to increase the counter. So we know that there is one more to be processed. But then we will need to know at what index we should process. I think we're already doing that in the on this file. So one second, let's go back to this. So we return a new we return a new instance. We increase the cursor, we check if we are overflowing, we go back to the list, and then we say we got one new response to be handled. Okay, so I think we're good on this file. Now let's go to the here, and then we have to go. Yes, this is the cursor that I was talking about that we need besides the one we already included. Uh, so yes, this is fine. Response queue count. And then I'm not sure. How can I do this? So we begin where we left. And maybe we can... Yeah, we don't have to... we don't have to make that check. I think we just need to check that we got stuff to send. And then I'm gonna say, all right, we're trying to send the first packet. If we send the whole thing, I'm gonna say like so. I don't think we have to do this. Okay. So now one more time. This index will refer to, I think we can remove this. So we will have all the packets to be sent, right? Like so. We'll begin here. So count is going to be 3 in this case. The head is going to be 4, or actually let's remove this so we have different numbers. So we'll have 0, 1, that should be 1 or 2. 0, 1, yeah, 2. And then we have the sending index, which on the first call, this is going to be 0. Yes. Now, when we send the first packet, this one, we will get rid of it. So I'm going to remove that. And count, so count is wrong too, so this should be 2. Count is going to go back to 1. Head is going to remain the same because we haven't pushed anything into the queue, and the sending index will be 1, meaning we're dealing with this. If we were to push a new element into the queue, let's say this, count is going to go up by 1, and the head is going to be updated as well. But the sending index will remain the same because we're still sending this one. So let's see if everything I just comment out is actually what's going on. So we'll begin by 0. So this is sending. Actually, I think I can rename this. So I'm gonna say sending index, so we can follow along the comments. All right. So we're sending this packet. We want to make sure that this runs as long as we got elements in the queue, and then we will increase I. I don't think we need this. I think we can simplify this by saying while we got something to send, just do it. There we go. So while we got something to send, instead of using I'm gonna be using con and sending index. There we go. So we're dealing with the with this packet. We try to send it. If we can't, we return, and then we will try again later when we can write into the socket. But if we send everything, we'll reset the buffer just in case. we'll reset the return um, counter, and we will increase the sending index, meaning uh, start handling the second or the next element in the queue. And then we have to remove one from the count. Yes. And then in here, we have to make sure that we don't overflow. So con sending index session, where's session? This one. Where's this one? All right. So if we're about to overflow, go back to the first index. And then we remove one from the queue because we just sent that packet. All right, so now this should work just fine. Let's see, let's close everything up. And the task, there we go. Actually, let me write the case in which we overflow. So we got Jesus. All right. So let's say that I add a new element here. The count is going to be up by 1. And the head is going to try to be 4, but that's overflow, right? Will be here. So we will go back to 0, and the sending index will remain the same. Yeah, that's fine. Yes. So now again, if we try to add a new element in the queue, we're gonna say x count is gonna go up by 1, and the head is gonna be up by 1 as well. So now there is this problem in which if we don't manage to send this before it gets overwritten, well, we may screw everything up. So maybe to avoid this, maybe we can say that count game session. Maybe we can say that count shouldn't yeah, maybe this assertion just works fine. So basically we don't try to send more than what we have, otherwise, like, we could comment this out and it should work, but the thing is we may overwrite some packets, and we don't want to do that. All right. So now I'm gonna go back in here, and I'm gonna say 8 and compile. What's the problem? Oh, this should be like that. And sending index. Yeah, this is fine. But this I think should be like this. Con. Is that so? No. This is con. What am I doing? There we go. Now it should be fine. There we go. And let's see. So we already got the login server. Yes, we do. All right, game server. Let's see if I can even log into the game. No. I cannot. Response size 0. What are you talking about? Did I mess something up? Game session. Response queue head. Head response queue count. Okay. And then Linux game server. Response queue count. Response queue count. Maybe I have to be more explicit like this. As long as we got something to send. Sending index. Packet size. Response queue buff plus written exit 0 0 count written 0 sending index. So this should be fine. Why are you not working? Game server. What am I missing? Um, Game session. Responses served. Response size. Sending index. Oh, why am I shouldn't be uh, setting that back to 0. Okay, one more time. Hey, look at that, nice. All right. Jesus, gamepad, bro. Okay, so now let's see if I can walk as much as I want. Seems like we're doing fine. Okay. All right. Let's see. Let's open up a new client. Test 2, test 2. Gamepad, yay. Okay, initialize. Bro. Okay. So now, where am I? Okay. So, I should be able to hit. Can I see the animation? Hey, nice. Take that. Nice. Take that. Very nice, dude. Very nice. Alright, so now we can attack and... Oh, did it crash? Crap. It actually crashed. Sweet. What went wrong? Again, we're hitting that bloody assertion. Are we not? This is weird. So what happens if we don't? What happens if we don't make that assertion? Like, or could it be like, mm, could it be that we're broadcasting packets in the wrong way? I don't, I don't think so. Session, yeah, I don't think we're broadcasting this in the wrong way. Char info, broadcast moving packet, yeah. All right, let's see what happens if we don't make this assertion. Game server, test, and test 2. Okay, so now I can attack you. I'm assuming the game will desync at some point. Yeah, there we go. So it hang and it's dying. All right. Do we have the disconnect from here? Sunday action failed just in case. Okay. Can I go up? Yeah, we don't have that many logs. All right, so we lost test 2. Okay, but I can keep walking in here. Nothing happens. Mm, I'm not sure. Well, I may have to find another way of doing that, of storing or handling the queue of packets. But oh well. Yeah, it's a bit more robust, but still, like, I don't want to have those special cases. All right, let's restart. Let's see if we got anything interesting in the logs. But I think we can Fine, close the connection. Reeve. This should be test 2. Yeah, I'll have to check or think a new way of handling these. Like it's not ideal. But at the same time, like yeah, I don't think the problem is in the broadcasting either. Oh well, I think maybe I can have like a huge pool of like packets to be used, and then everyone uses that, and that's it. But yeah. All right, let's see if we can comment this. Build. So yes, attack. Open. I'm gonna say after attacking, do damage, and then find a better way of handling queues of packets, since the current one isn't reliable. Okay. Response attack. Add it to the here. Calculate damage. And the flags, I think we can copy the flags from here as well. Um, I'm gonna leave this. God damn it. Okay. From L to J. So now we know what the possible flags are. And then open to do properly handle this. Stage. What is this? Send my target response. Broadcast attack through just a test. Broadcast and test attack packet. All right. Stage. Stage. Yes. Yes. And I kind of like these comments. So this is how the queue works so far. X packet ready to be sent. After packet gets sent, new packet gets pushed in the queue. So on and so on. All right. And anything else? No. All right. So I'm gonna say add attack packet and slightly improved response queue. Still not quite there yet. Need to find a better way of handling it. Alright, commit, push. Well, we didn't quite fix the response queue, which is a bummer, but to be honest, I'm very happy with how the logs came out. Like we can exactly pinpoint where the problem is, compare as to previously that we didn't know why the client or the server crashed. So that's an improvement. Um, Still, I gotta find a better way of handling that bloody response queue. But I think for now this is good progress. Yeah, let's call it a day. Um, Remember that you can see or even contribute to the project if you want to in the GitHub repository. I'm going to be leaving a link down in the video description. Also, if you would like to contribute, sorry, if you would like to support me on what I do, you can do so in the Coffee page, which again is going to be linked down in the video description. Uh, Also, another way that you can support me is by clicking on the subscribe and like button if you like what you see. But yeah, I think we'll uh yeah, I'm a bit tired. Um yeah, guys, thanks for watching. I hope you enjoyed the video, and I'll keep posting a new video soon. Take good care. Bye, guys.